Today, we're going to have a look at coastal ecosystems. And the first one we're looking at is coral reefs. Now, coral reefs form through the build-up and compression of lime-secreting polyp skeletons, meaning that most of the coral that you see is actually dead. So only the upper and the outer parts of the coral reef contains living coral polyps. So when one generation dies, the next generation grows on top of it. So their hard calcareous skeletons form upwards and outwards, growing the reef. Now for corals to start growing, there needs to be a solid surface, which could be either from like a shipwreck or other debris. So they cannot just start growing on sand. Now, coral reefs run parallel to the coast, with breaks where the river mouths exit. So let's look at the formation of coral. Now, if we zoom into one of these corals and we look at the different parts that they're made up of, we will be able to see two distinct layers. The first layer, which will be on top, which is usually the colorful layer that we see when we look at corals, that would be our polyp coral. So that would be the living part that we know as coral. There is then another living layer right below the coral polyp, but this isn't part of the polyp. This is actually part of a algae called zooxanthella. Now, this algae lives underneath the coral polyp and it creates a symbiotic relationship with the coral, giving it several different nutrients, whereas the coral then protects the algae from other factors that might want to eat it or destroy it. And then below that is, of course, the calcified skeleton, and this makes up the coral. Now, if we look at the distribution of coral reefs, we can see that they're mainly in kind of the center, so around the equator of the globe. And this is due to several factors. Now, remember, coral being living as well as the fungi that lives with it needs certain factors or certain environmental conditions to be able to survive. The first one is temperature. Now, corals cannot tolerate water temperatures that are below 18 degrees Celsius, but most of them grow best between like 22 degrees Celsius and 25 degrees Celsius. Some corals can, however, tolerate temperatures as high as 40 degrees Celsius, but this is only for a short period of time. So by knowing this information, we can now see that most coral reefs grow between 30 degrees north and south of the equator. So this is in the tropics of the Capricorn and the Tropic of the Cancer. The second environmental condition that's very important for corals is light, and they need light to be able to photosynthesize, and that's because they have the algae, zooxanthella. So this algae is obviously photosynthetic, the polyp is not photosynthetic. So it needs light to be able to photosynthesize and live. Then, the water quality is also important. Now, corals are generally found at depths of about 25 meters. This is so that sunlight can still penetrate to the bottom where the coral will be found. The water must also be clear and clean to allow photosynthesis to occur. If there's any debris or dust or silt, this will cover the coral and light will not be able to reach the coral. Then lastly, for our global distribution factors, we have salinity. Now, corals are obviously marine animals, so they need salty water to survive. So they need between 32 and 42% salt water to be able to survive. Now, there's some local features that also affect coral reefs, and the first one's wave action. And this is a very sensitive one because wave action, like we spoke about in the earlier lesson, helps with oxygenation, it also cleans water, and this helps the coral survive and grow. But coral can't be in too shallow water where the wave action might destroy it or even damage the coral reef. So there's a fine line between no waves and too much waves. Then there's also the exposure to air. Now, although corals need oxygenated water, they cannot be exposed to air for too long. This is because they'll dry out and they'll die. Now, when they die, this is called coral bleaching. And this is when you see that white coral forming, which is dead, like in the previous image. Then we have sediment, and we spoke a little bit about this already, but all corals need clear, clean water so that the algae can photosynthesize. Now, by decreasing the amount of light available, sediment in the water will block regular feeding habits and interfere with the photosynthesis of the microscopic algae. So the corals provide algae with a home and, of course, materials to photosynthesize. In return, the algae produce food, oxygen, and help with waste removal as well. So this is a good example of a symbiotic relationship. Now we also get different types of coral reefs. It's not as much as the different types, but the different formation. Now the first one is a fringing reef. Now these are low, narrow bands of coral that runs parallel to the coast, and they form around a land mass. So at high tide, narrow, shallow lagoons will cover them. So their outer edges will slope steeply down to the sea beyond. The landward side of the reef has a higher outer edge that rises to the high tide level. So a good example of this is the coral coast of Fiji, as shown in the image. Then we get barrier reefs, which are wide, deep lagoons that's below at depths at which polyps can live separate. So these are usually between 500 meters and several kilometers from the coast. So they're quite far away. Now, we all know this example, and that's the Great Barrier Reef. Now, the Great Barrier Reef consists of about 3,000 reefs, and they're separated by channels stretching more than 2,300 kilometers. It's also one of the only reefs that can be seen from space. The last one is atolls. Now, these are narrow, ring-shaped reefs. They consist of a coral rim that encircles a deep lagoon. Sometimes they may circle and protect an island, and there's channels between the islands connecting the lagoon to the open sea or ocean. Now, a good example of this one is the Maldives, which is called the Suvadiva Atoll. Now, if we had to sum up the three differences, a fringing reef will form around a landmass, and it will stretch from the landmass outwards to the seabed. A barrier reef will have lagoons that's separated from the landmass, and the atoll, most of the time it will not have an island, but it's a ring-shaped reef that basically consists of a coral rim that surrounds a lagoon. The next ecosystem that we're going to have a look at is salt marshes. Now, this should not be confused with estuaries. Salt marshes can be found in estuaries, but they aren't known as estuaries. Now, salt marshes are communities of non-woody, salt-tolerant plants. Now, they begin as tidal mud flats, gaining height as more sediment is deposited here. So this builds up to and above the level and frequency of tidal flooding, ensuring that the soil never dries out and remains muddy and kind of sticky. Now, pioneer species of halophyte plants begin to colonize. Now, halophyte plants are plants that are very salt tolerant. As these plants die and add nutrients to the soil, the sediment builds up. So this makes the conditions more favorable and other species can start to develop. So here we can also see an example of succession, just like what we went through with the dunes. Now, the daily rising tide will flood the lower marshes. There are very good coastal defenses in some areas, acting as a natural buffer against coastal erosion and flooding. And so these plants, the halophytes, roots will keep the salt marshes soil in place and keep it from going into the ocean and being carried away by waves. However, human activity has destroyed them in many places for agriculture or for development, putting them at risk. Now, salt marshes are found all over the world and are not temperature dependent. They're an ecosystem in the intertidal zone. Now, the intertidal zone is the coastal area between high and low tides, like we said in our first video. Now, they're typically very flat with numerous channels running through them. They kind of form in coastal areas that are well sheltered, like inlets or estuaries where fine sediments can be deposited. They can also form in areas behind spits and artificial sea defenses where tidal waters can flow gently and deposit fine sediments. And they can also form in brackish water. Now, if we look at the global distribution, we can see that most salt marshes are either found above the Tropic of Cancer or below the Tropic of Capricorn, not really around the equator. The last ecosystem we're going to have a look at today is the mangrove swamps. And this always makes me think of some American movie. So mangroves are trees that live on the coastline. So they sit in water between 0.5 and 2.5 meters high. They range in size from small shrubs to trees that can be over 16 meters high. So they have numerous tangled roots that grow above the ground and form dense thickets. And that is what we see here, where the roots kind of form above the soil. Now, this root system is complex with a filtration system to keep the salts out. Some have snorkel-like roots that can stick out the mud to help them take in air. Because remember, the reason why your plant dies in the house when you overwater it is because plants also need air. And usually, roots use the tiny little air pockets in soil to take in air. But if the plant is submerged in water like mangroves are, there's no air bubbles in the soil. So these roots will grow outside of the soil to be able to get air to respirate. Now they can also use prop roots or buttresses to keep their trunks upright in the soft sediment at the tidal edge. So if we think about this, because the soil is submerged in water, it's not good at keeping plants or trees upright, as it's not a good anchoring system. So these mangroves have several roots that they call prop roots to give them more stability. Now the roots can trap mud, sand and silt, which eventually builds up the intertidal zone into new zones. Now, the mangroves are found in warm tropical waters. However, unlike the sensitive coral reefs, mangroves are highly adapted to changing conditions. So this made them one of the most successful ecosystems on Earth. So if we look at their global distribution, we can see that they're similarly distributed as the corals, mainly around the equator and going a bit north and a bit south, but not into very cold waters. They keep around warm waters, just like coral.